Hernan asked a very good question, which I refused to answer, because I thought I should answer in front of everyone. He said, well, but when we were doing in-place merge, we used rotate. And what's the complexity of rotate? We will study rotate algorithm if we, yes? N minus 1 what? Well, this is tricky because it depends on the kind of iterators which you got. If you have random access iterator, the best theoretical algorithm does n plus GCD and whatever these two things, the n1 and n2, assignments, not swaps. So we could get GCD is small. So, or at least on the average, GCD is very small. The average is slightly larger than 1. So we could get almost to n assignments, which is much less than n swaps. For forward iterators, it happens to be n minus GCD n1 n2 swaps. We'll study all of that. And it is roughly n swaps for bidirectional iterator. So it's n swaps is three n assignments. So the tricky thing is that as we will observe, we could use a faster rotate than the rotates in STL, because if you think about it, we have this additional storage. And if things fit in the additional storage, we have a buffer now, or at least theoretically we will have a buffer. And eventually, again, I was waiting for you to sort of discover that, but let me allude to rotate. Let's assume that you want to rotate these two things, and you have enough storage, whatever that means. How many assignments do you need?
Plus assignment first.
Yes. It's n plus n1. Which is less than, for sure, less than 3n. All right, so we shall see it's things, the moment, we start using this buffer, many interesting algorithmic ideas could be exploited. Right? But we haven't got, we have to get to that point. You see, it's a fairly, there are all these, here, let me philosophize for 2 minutes before we write code. The problem with programming, with the designing components, decomposing the system, is that you do not know what is right in isolation. You never know what's the correct interface till you see how it's used in other algorithms, how these algorithms are used. So you have to sort of, this is why you have to sort of do this, then to do that. Then eventually things start emerging. You say, that's infinite process. No, it is not infinite. That's the wonderful thing about life. It sort of terminates. I cannot prove it, of course. But in practice, if you start feeding things, you sort of discover what you need to return, what you need to pass, what is the right thing. And that's what, in some sense, I am trying to teach. In some sense. So now let us open a file called say merge.h. How are we going to go about it? Anybody, do I pass the spoon? What technology do we use? Oh, free for all? Free for all? Free for all. Okay, so what is the first thing do we write? Merge with buffer. Okay? And let us, just for an argument's sake, let me suggest something. Let's assume that this buffer is big enough. Eventually, we'll have to figure out how to deal with limited buffers. Right now, let's assume that somehow whomever is going to call will assure that. Yes? So what's the interface? Anybody wants to have a go at the interface?
Well, we take 6 pointers, 6 iterators, 2 for one range, 2 for the other, and 2 for the buffer.
How could it even work? Range, buffer, and what do you do?
One place to write the output. So
Then why do you need a buffer?
oh, we're doing this in place. Sorry. So that's right.
Again, guys, we have to remember that if we have some place to write it out, we don't actually need any buffers. But let's right now not to write it, we will write it. But right now let us rely on this wonderful thing which is called std : merge, which exists and which will take one range, another range, and output pointer, output iterator, and a comparator. So we have something like that, and it will merge. We'll implement a better one ourselves. But right now, let's assume what it exists. So what kind of an interface do we need?
First, middle, end, buffer start, buffer end.
Do we need buffer end?
Or if we assume it's big enough.
Oh, okay. If it's not big enough, we're in trouble. At least we need to do sophisticated algorithm.
But the interface should, well, yeah, I guess we could just take one, but yeah.
Interface will evolve. But for the most simple thing, when the client has to assure the buffer is big enough.
Sure, why not?
Okay? I mean, how do you want to proceed?
Shall I take?
Yeah, that works.
Okay, template. Type name I. That might be sufficient. So, compiler. Oh, okay, fine. Comma, type name
Yes. Enter. Okay. I issue a wording at this point. I issue a wording. But let's proceed.
middle outputs.
I issue a wording, but let's proceed.
It's okay, we'll fix it. It doesn't do return anything. Well, okay, it needs to. No, it doesn't need to. It's going to merge.
It leaves the input to the file for now.
So just say void.
It would be, so, by the way, just quickly, what is I? Compare, we know it's some strict weak ordering, one value type, but what is I?
Forward iterator.
He says.
Void merge with buffer. First, I first, comma, I middle, comma, I last, comma, I buffer. Stop.
And the CMP.
No. But now, guys, let us think. Let's think about using this stuff. Let's assume that some person, could it be Paul? Is he a person? He's a person. He wants to apply this thing to sorting linked list. Could he do it?
Oh, we might want the buffer to be of a different iterated type.
You said it.
Alright. So add a type name B for the type name pair, and make the buffer be of that type. And we should probably pass in comparator.
Buffer doesn't have to be of the same type. It's basically, typically, what is buffer going to be? Anybody wants to guess? Going to be an array. You could use, if it so happens that you have a handy linked list which is not good for anything else, you could store the stuff there. It will work. But demand sort of, what did we discover? We discovered a general rule. I don't. We said the client has to be sure that buffer is big enough. So why do we need something to represent its size? Eventually we will, but not for this. Let us go step by step. But what is the general principle?
If we are dealing with multiple ranges, they could be of different types.
General relaxed type requirements. When things don't have to be the same type.
Yeah, by B is also more iterative.
Yes. Huh?
CME
Is
sort of binary predicates.
strict weak ordering.
Strictly ordering with the
Whatever.
range
Yeah. And they hopefully they have the same value type, B and A. But Bjarne will explain to us next week how to say it. So I hope.
open curly brace. First we need to copy first to middle into the buffer. So is there a std algorithm thing for that?
Copy.
Buffer.
Yes. That is nice, but okay. Let us see why it's not quite right. Let us. I'm not going to say anything. I have to restrain myself because it's so hard.
We need to know, buffer might be bigger. So we need to know where the thing ends.
How would we know?
Hopefully copy returns it to us. But who knows?
Copy does return the last output iterator where it outputted. Oh, so how very handy. Okay, now we, by the way, see why copy returns.
Okay, and now we call std merge.
And we have to write it carefully.
Because the first one should be,
First one has empty space, the first half roughly.
I want to maintain stability.
We want to maintain stability. So you guys maintain stability.
What is the API
Signature of merge.
Merge, range, output, compare.
Okay, so buffer comma buffer last.
Yes.
Um,
Buffer is before the other range because that's the first subrange. Everybody?
comma middle plus 1. So we need to advance the middle somehow. No, wait, middle comma last. That's it. That's all we take. Comma first. Comma same.
And in spite of our friends on the standard committee who tells us that it's not going to work, it will work. And we'll do exactly what we want. They tell us that input ranges and output ranges should not overlap. And here, oh, how they overlap. But it's all right. It will do exactly what we want.
Okay.
Okay. Now, let us try to do sort. Actually, what I would suggest, just to make Param's life easier, could you go and get the other sort and just put it there? If you see what I'm saying. This guy. So what do we need to change here? Yes or no? Is he right or wrong? Is he right or wrong? He wants to allocate the buffer here.
It's either given to us or we allocate.
That is true. It's known as the law of excluded middle. Cannot argue. Aristotle says that it is so. Another Greek. Aristotle.
It seems that the buffer is an internal optimization of our algorithm. The caller doesn't need to know it exists.
But this is recursive.
Yes, we're going to need a wrapper if we're going to do recursion. So we allocate it in the wrapper, and then we call the recursive function. Not a wrapper, helper. I think it makes sense to have a thing that allocates the buffer as a convenience for external users, but it also makes sense to have another function that takes a buffer. Yeah, so the recursive one will have to be. The recursive one.
Okay, what it's going to be called? Yeah, something like that. Huh?
And just use one. I typed in B to the template.
I didn't say anything. Yes, because buffer is buffer. I mean, we have to deal with this buffer thinking.
And before the R, we need to
Okay, no. Think about it. Think about it. Let's think about it. Where does it go? Before or after?
the first one it went before. So,
The first one, it went before.
well, since you want
And
to default the compiler,
therefore, maybe we should go and fix it. Let me argue. We're extending the interface. We had the interface first in R. We're extending it. This is a suffix. We want to sort of, if you see what I'm trying to say, sort in place. We are sort of extending. So I wasn't particularly watching the first one, sorry. But it's the same thing. It's like merge in place with buffer, except, right? So buffer.
buffer, the sort, the merge in place call.
By the way, observe that this we need to adjust. The names probably change. And we need to keep passing down the buffer. This is the beauty. We sort of, the buffer is just. And how do we call it merge with buffer? You see here, of course, what we could figure out. I was a little bit devious last time. I assured that we stored the middle and last, we didn't really need middle, but we do now, because it's merge, whatever it is called. No, but I could have just plugged it in.
Oh, right. Merge with buffer. First, comma, middle. Delete the last somehow. So, if,
What do you mean? We need the last. It's right there.
last.
We have everything. You see, this is called serendipity, which means that we're doing something right. By the way, when things fall out easily, it means that we're somehow on the right track.
Probably make merge with buffer also take R instead of sleeping.
We're not done. We're not done, guys. Now we need to create something in order to be able, let's say, we want to use this guy in our framework to get timing. And let me tell you, the one in the framework requires this iterator, that iterator, nothing else. We have to somehow get rid of all of these guys and replace them with some other guy. Could we do it?
Well, we need the function that allocates the buffer to start with.
And it would need to know the length. That will require
We need an analog of the other function.
yeah. Okay. Right. Now everything is coming together, and you basically don't need to write code. You need to write this wrapper glue, right? It's not nothing. This is where the work is done.
Sort in place with buffer.
No, it's not for sure list. It's not list. We're not sorting list.
Sort in place.
Sort in place with buffer. Okay. I misheard. Sorry. I probably, when I sit here, Nick cannot see anything.
So this will take just first and last.
Also on the other flag.
It also needs to have something about templates.
Yeah, but each of them.
Then take the one from the other
You
flag.
can take the one. That makes sense.
Just like that.
Do what I do.
We'll need a little bit more, guys. A little bit more. So this is good. Very good. So
So we want to allocate the buffer here? I mean, I really think we should have a function that takes a buffer and a function that creates a buffer. But, for the
what? I do not understand what you're saying.
I mean, as a user, I might have a buffer,
Use.
Oh, then just call the other one. Yeah, fine. Okay.
Or we could, you mean to switch it from N to, you could do it yourself.
Sort in place N. So,
There are a bunch of stuff, guys, which you need to think. It's trivial, but it requires thinking.
Get the distance between first and last.
Yeah, that's like we did here. But we do need it before we pass it. Yes, and for that we need to name it. No, it doesn't work.
And we need to get the type out. So it does iterator traits distance, difference type, distance type, difference type. D,
I would go for n,
N, okay, N,
since that being an integral type.
yeah. N equal to that. We know that the buffer we need,
I don't think we want to compute it twice.
Yeah, yeah, when we pass it.
the compiler will. And call sort and place N with buffer.
So when you need to get a buffer,
And we need a buffer. How big does the buffer need to be? The buffer needs to be N over, so we just copy that half code from line 17 and make a buffer of that size.
actually, I would recommend the following thing. I mean, what kind of a buffer? I mean, what's the easiest way to create a good buffer? Easiest way of creating good buffer. We need to do bunch of includes, guys. Just reminder before we attempt to.
Space buffer.
No, no. Yes, but n is good.
Do we want a smaller buffer, or N is a little big, right?
Yeah, and it's a little big. How big is the buffer we need? Yeah, and right shift 1, I would say. Because let's look at the very top situation. It's the very top situation where you need the largest buffer. We sorted this half and that half. The half here is going to be the size n over 2. If you look at the code, it's going to be size n over 2. So how large a buffer do we need? N over 2. You say, we're cutting it, but that's what programming is about. You cut it so that there's nothing left.
Yeah, so this function is done. We just need to include everything we want. Is there a return statement and everything? Oh, it's wide. Okay, so that's fine. So let's go to the top
That's not bad.
and include vector.
We need to include bunch of stuff. Okay, let me show you things. Yes, this is for copy and for merge. Sadly enough, let us slide down, for this and for this, we need another header. Anybody knows which? Iterator. So this is actually has a container algorithm, sort of. What? Thank you. And for less we need functional, because Bert tried without and didn't like it.
Okay. Now let's go to the harness.
Let's go to the harness. No, it's not the harness. Harness is .h. And lo and behold, line 14 is already there. Aren't you? So, no, slide down. Slide down. Slide down. Okay, so we need we need to put our name. I didn't know which name you guys would pick. I apologize. And we might have some problems with aligning.
What was it called? Sort with buffer? Sort in place with buffer.
Right. And this,
You can update the names already?
what names? Names are not needed, throwaway names. I apologize. I was explaining to you what was going on yesterday. So you need to, or we could let us keep it, let's call it sort merge because otherwise tabs, I'm not sure of my tabs.
Okay. Let's see what the compiler thinks.
03, please. Try, just go back. Yeah? Like something like that. It compiled.
It's fast. Faster.
Yeah, compared to the second
Observe the amazing thing. Sort of, we will analyze it, let it go, and then we will talk about what we. You see that, of course, we could go further, but I want to show that we could do it in class. There are some unpleasantnesses in the beginning. Why? And not doing, because whomever the guy was who wrote this, he knew about insertion sort. So we could clearly see that. But as we grow, the amazing thing, what was we wanted to get within 5%. We didn't get within 5%. But we got awfully close. This is like 10% without doing any work. Which just shows you that now we know, again, sort of, it shows us this spectrum. Right?
So how much memory does stable allocate?
Stable allocates all, well, no, it's not complicated, but you heard the story, let me tell you the story again. Sort of when I was implementing STL, I said that the vendor, the OS vendor, knows how much extra storage is available. So I'm going to have this function called get temporary buffer, which allocates as much physical memory as is available at this moment. But it is vendor specific. You cannot do it as a client. You don't know. I mean, there's actually no call in Unix which tells you how much physical memory you have, how much of it is already used. It's just impossible to find. It's easy. So I said that's a function. The vendor is, this is the only outside hook STL will use. But I needed to ship it. And in order to ship it, I couldn't just say this requires an OS hook. So I wrote the following thing. I wrote a function called get temporary buffer, wrote // this is bogus code, needs to be replaced. And then I did the following thing. I did malloc n, sort of, you ask how, the interface there is that you ask for n, and the system gives you as much, not more than n, but as much as it got. Half n, quarter n, 1/8 of n, I don't know. So what I did malloc, and if it was just 0, then I asked for half. Then I went binary search. Is it a useful piece of code? No. as I said, slash slash, this is bogus code. The only reason I wrote it, because I needed to ship. I mean, so that people. Guess what happened after that?
It's in the standard.
Nobody implemented the rule.
They did, they changed this function. How did they change it? They removed my comment. So every implementation, Unix, Microsoft, Apple, all of them just do the same stupid binary search. I have been giving talks about, is it the first time I mention it? For decades, I have been telling this story, sort of writing about nothing. This is still there. I think it's a very useful function, by the way. Whatever, you write code, you come to some point and say, I want as much memory as the system has. The system should know that there is this physical memory. There's something, because right now you know there is this virtual memory, but virtual memory is utterly useless unless it's backed by physical memory. So by the way, therefore, my function right now always returns whatever you ask because it just allocates. You know, it used to be a problem when we lived with 16-bit address spaces. So right now we have 64-bit address spaces. So it will allocate all the way up to, you know, and it doesn't stop, but virtual memory, in some sense, is a figment of imagination. It does not exist. As Seymour Cray used to say, how did it go? You couldn't simulate what you do not have. I mean, if you don't have memory, you do not have memory. The algorithm is not going to work. Virtual memory, you realize that virtual memory is utterly useless as memory. It's not, I mean, it's a very powerful thing for remapping things, but you know, if your algorithm working set doesn't fit into physical memory, you start thrashing, and fundamentally your program will not terminate. It's not, I mean, your memory starts working at the speed of disk. That's not good enough. So, right? So, but this is none of our problems. So I'm explaining what the poor guy is doing. Here, let us try to, we will try to sort of provide interface. And here we did observe that Param's code could be used correctly, since we have the interface where the buffer is allocated by the user, and the user should know. And again, when I was proposing STL, every function which needed extra storage had an interface with buffer. Guess what happened? It's all gone. Right. They all gone, and instead there are functions which do call get temporary buffer, which does binary search, whatever. It just shows you how imperfect life is. And this is, again, this is over 20 years ago. 20 years ago? 20 years ago. It's old stuff. So, okay. Let us at least start sketching, since we're going, by the way, those of you who desire to finish the entire program will have 2 weeks to do that. Are we on the right path, in a sense, designing things together? Or Bert is not sure? Okay. So let us go and see what we could do more with Param's code. Param is not actually your code. It's our code. But, you know, I have to call it something.
So we should look at our list of ideas again? Or should we look at
No, let's look at the code and see if we could do something quickly even now.
Oh, all right.
Low-hanging fruit?
If there's any low-hanging fruit, which we, so what could we really try doing even now in 15 minutes? Should I say? or you want anybody has an idea of what could be done. 15 minutes is a short period of time. But not sort. Let us do adaptive merge. Remember this merge? So the idea here, what we want to do is to try to make this to be adaptive algorithm. And what is the main structure? How will it look? Anybody knows how will it look? Where should we, I mean, we should always steal the code, right? Especially from ourselves. And what I claim is that we already have a piece of code which does what we need to do. Merge in place. Let us steal merge in place. By the way, the merge in place, if you're I'll give it to Bert, let him suffer for 15 minutes. No. We want to, since copy paste, because we want to muck it. You know, I don't know how to muck files which are included. You, by the way, you should do what you did because observe. Let us just sort of, there are these two functions there. Do we need to do anything with them? Now let's look at them. Let's look at them. What do they do? What do these two functions, that's the functions which do work, at least at the first approximation, do we do anything, need to do anything with them? They don't do anything recursive. So when they call, we call just them. Except for one potential thing, we might not want to do it now, but let us just. We might want to change them with the version. Could you show me one of them? Rotate with buffer. Since we have at that point, we have a buffer. But let's not even bother. This is, again, I'm just investigating. You see here we have the rotate, and we could possibly pass buffer here and pass buffer to rotate, right? Possibly. It's not, it shouldn't be. Bert, shut up. You
Yeah, no, that might help. But you wanted to just do the merge adaptive for now?
Yes.
So that's only the main one.
Yes. And to do adaptive, again, let us talk a little bit about the interface. Right now, in what we would call temporarily params version, you just pass a buffer. And the size. Right? Because we need to know, we need to adapt. We say, oh, we don't fit. So let us look at the code.
So we're going to have a couple more arguments, the buffer and the size of the buffer. B buffer.
And let us assume it's the same n. We could create other n, but since we're going to be comparing additions of this n, or whatever, we're going to make this n.
So guess we need to know the size of whatever we're merging.
Why? Which size? This is, we're merging them in place. So the first, I'm just reminding you the interface. F0, N0 is up to here. And then the second one is up to here. We guarantee that the distance between F0 and F1 is N0. So F1 is our middle.
Okay.
So if N0 is less than buffer size, then we can
Yeah.
call it our. If N0 is less than buffer size, we can call it the merge we just wrote.
If N0 is,
The length of the first part is smaller than our buffer.
yes. By the way, what if the other part is smaller? What if the second half fits into the buffer, but not the first part?
We already picked, we always, we picked.
Didn't we pick the buffer size to be half, to be the same size as that first part?
You could merge starting from the right side if you're tricky. Right? Copy the right side and then just merge, but this time from the right. I don't know.
We can inverse 3 times.
Yeah.
Merge from the end, or you can copy the front to the later part.
That's extra move.
Or you can merge from the back.
With a forward iterator.
This is exactly, no. I mean, listen to what Bert said. The forward iterator makes it a little difficult. Of course, if we have bidirectional, then we can merge backwards, if you see what I'm saying. Right? By the way, that is what stable sort is doing, and this is why it's not forward iterator requirement. Whether it helps at all is not clear. Why?
So the hardware is good at going forward?
No, it's effectively, you see, we tend to be pretty evenly divided. So trying to optimize, it's one of these things which I believe does not help. We could test it ourselves. So I'm just, okay? Or we do it next time. Or you think we'd do it now?
Yeah, so like Prom said, if N0 is less than buffer size,
If N0 I would still keep the first thing or equal. If it's equal, it still will fit.
then we call, what was it called? Merge in place.
Merge in place with buffer.
And merge in place with buffer. I've already forgotten its arguments. It takes
S0,
F0, F1.
That's a little inconvenience. We actually do not have last. So we have to go get last. Or we could write a version of the other one which takes counted range. Yes?
For now, we just write advanced. We're writing it with arrays. We're using it with arrays. So.
Yeah, but let's write it correctly, nevertheless. Because with array, I mean, in other words, if we use advance, it's just 2 lines. Just 2 lines, 2 lines, 2 lines, 2 lines down, wherever we were. Last. No. I'd F1 and move it. It's annoying, but for common case, which is an array, it's literally no code.
And return.
I think it might just be called merge with buffer. You check the
Yeah.
function.
Merge
Yeah.
with buffer.
Merge.
So we need to rename this thing and call it probably merge adaptive. And now we could literally try without much work. We could see what happens if we give it, say, 1/8 instead of 1/2. Which recursive calls, yeah, do need renaming. Otherwise, yes. And not just renaming and adjusted. Yes.
Adaptive should still have
Underscore n. Yes. And we need what? Original one didn't have. He will fix it, yes. Okay, now we're almost ready to test something. Let us go and see what will be temporarily called params sort. And let's fix it. Bert, tell us how to fix param sort. It should be in the same file. So we could probably copy it, so we keep both. This. No, but we need, guys, sorry, we need both. It's not just the top level guy which we need to fix. It's the middle level recursive guy which we need to fix too. You called it sort? No, this is sort Bert. No, sort param was the old one. No, this is actually needs to be called sort adaptive. Yes.
Can we just change Bert's
And you need to change recursive calls. Almost there, guys. Almost there. And this we could call sort Bert or something. Except we need to change adaptive. it should be, I suspect that it should be sorted up to n and shift by 3. Yeah. Let's sort of see what happens.
What will size return here? Is this correct? Just declare a variable.
Buffer dot size. Yeah.
Isn't it after the number of elements?
Yeah, that's the number of elements.
Even if
we're not appending, we didn't reserve, we actually added.
It will do as before. Well, I mean,
Then we want to try
we're
with
calling
this.
dot size. I wasn't sure if the buffer is just reserving that space or.
no, it's really allocating it.
The recursive calls need the underscore and not call the step size.
Ah.
About 10 line. There.
Shouldn't we try with the same buffer size first?
Just to see whether it works. Let's smaller buffer. Let's be brave. Come on. Live dangerously. By the way, we could print now four columns. Test sort.h. You don't need to include anything. You need to add sort BERT. And you need to put it in the function table. There. We almost made it. Yeah.
How long function we need
Merge H, can that template ignore deduced conflicting types?
Where is it? From the lines?
Just surround buffer size into n. Yeah, try. What? Merge adaptive end. Why it's not merged? What happened? It says that not enough arguments. Let's count. This requires 7 arguments. We're calling it someplace with 6. Merge adaptive, this is correct, this is correct.
Oh, we're using, that's not counted range. It's using middle, middle and last, or,
Yeah, that
or
should be.
Yes, we need. Yeah.
And we need to add middle, and then we're adding in n minus half.
N minus half, yes, thank you.
We have last here, which sort of adaptive needs, which we
Compiles. Maybe it will run. Of course,
I lose.
but observe, it's getting closer and closer. Yes, you are expected to lose.
Did you change the buffer size back to, oh, yeah, we were going to.
Right, so we went down by roughly factor of 10 of how much extra memory. We are losing, yes, we are losing, but we are losing less than 20%. Right? Again, we have to see what happens after we start adding insertion sort. And rotate and other things. Yes. There are just so many. Could we go to the list of the ideas? Because we don't have rotate there. We will put all of that into the whatever. Ryan promises. Okay, guys. See you next week, but we will continue on that 2 weeks from now. I'm actually happy with the way the class went. I don't know about you guys, but
We're gonna meet in the same room at the same time.
yeah, it's the same class, the same room, the same time.